Look, I'm just a geologist. I like rocks. I love rocks.
Well, good evening, gentlemen. My name is
Hey,
Steve.
we're back again. I'm Chris.
I'm Jesse.
And we're the Flannelcast.
Casters.
Flannelcasters.
Multiple.
We're a bunch of wheels on furniture.
Oh, yeah.
Oh, casters.
Actually, I was building, as I told you earlier, I was building my grill, my brand new grill, and I was putting it together, and Evelyn, my daughter, walked out and she goes, Daddy, can I help? And I was like, sure, you can put the casters on the bottom of it. And she's like, what are you talking? She's like, what are the casters? I was like, these things. She goes, these are wheels. I was like, oh. Well, you know, when it's like furniture, we call them casters. Like, why don't you
That's
just call
funny.
them wheels? I was like, I don't have a good answer for that.
I think a caster is a wheel that can move in any direction.
Oh,
I think a wheel just goes in one direction, but a caster is a wheel that can pivot on an axis in any direction.
I really wish you were standing there when she asked me that.
So I could admonish your 5-year-old or 6-year-old,
Yeah,
like, no,
Very good.
come on, man.
So, yeah,
Well,
you would need to stand on the other side of the fence.
Yeah, exactly. 6 feet away. Yes, of course.
Well, everyone, we don't have a guest today, but we have like a throwback to like the old school episodes from actually. What was this? It was just a three. It was like 3 weeks ago, right? The old school.
This it blends from week to week.
Yeah, I don't
day
know.
to
We
day.
had
I think it was a month ago.
Yeah.
So 4 weeks ago.
Great guests, and we're still going to have guests on. It's just that we just throwback episode today. Just hanging out with the boys. Get back to the roots. Yeah. So, So we're just going to talk about some news stories today. Figure what's going on in the news and current events.
Yeah, and to be honest, I'm lacking in the current event. Like, I used to apparently get all of my news in the car, and now that I haven't driven in months, like, just like, oh, that famous person died a month ago. I had no idea. Or
I just found out yesterday Nate Dogg died like years ago.
Yeah,
I didn't know he was dead. I don't get out much.
Maybe after we stop recording, I'm gonna ask for context that came up. But yeah, it was just the 9-year anniversary of his death in March. So.
We'll talk about it after the show.
Yeah, join Patreon to hear Chris's exciting train of thought that led him down to where is Nate Dogg these days.
Wonder what it is always a bummer when you're like, oh, what are they up to these days? And like you do a quick Google search and you're like, oh shoot, they died like 8 years ago. A, I feel terrible because I didn't realize, and B, like that's a bummer because
yeah, it's like a whole nother wave of sadness. Like, I'm not going to get to see them for the thing that I was Googling them for in the first place, and I'll never get to see them again.
Nope, never.
Yeah.
Real lose-lose.
Yeah. So my current events are like, I basically get my news from Jesse and Jesse's Corner every week.
I somewhat obsess about the news, and I've had to dial it back because when you're stuck at home all the time during a global pandemic, it really takes a toll on you. So, Anywho, I'm not as up on my news either. I was actually.
So this is great that we're doing a news podcast today. We're basically telling everyone like we don't know what's going on right now. We know what's going on. We're being silly right now.
I will say I was reading a story a couple days ago about Alfred Wegener. That's where I'm at right now. I'm like,
nice.
What I said? What's Alfred Wegener up to? And I googled.
Nope. His body just thawed out of a glacier in Greenland.
Too
soon.
I don't think he was ever found.
No, they never found him.
Nope, 1930.
So in case for the listeners that aren't familiar with Alfred Wegener, He's the guy that came up with he coined the term continental drift, right? He was like pre-plate tectonics. He was like, I think these these tectonic plates are moving around, but he really couldn't find a mechanism.
I don't know if he coined the term, but he was big on, he was like, this is what has happened. But yeah.
He basically looked at a map of the Earth and was like, it looks like South America fits into Africa. If you close the Atlantic Ocean, basically everything all fits together.
He wasn't the first.
No, lots of people had thought that, but he was the first one to kind of prove it with other evidence other than, I think these puzzle pieces used to fit.
He didn't prove anything, and
no. He had evidence. He had fossil evidence. He had glacial striation evidence. But
the thing was, I don't know about that. I know that he didn't have basically people were saying,
how
are you moving a plate?
Exactly.
How much does, as I always tell my students, like, how much does Asia weigh? It's huge, and so what's moving that? What
like the band Asia?
Yeah.
Like the band Asia.
Not just Asia, Eurasia.
Eurasia. Exactly.
Well, which weighs more, the band Asia or the band Europe?
I think it's
it's the final countdown right there.
That's a super group that's lacking.
Yes, we could just call them the supercontinent.
Oh man, Asia, Europe, America. Pangea of supergroups.
Yes, we'll call them Pangea. That would be fantastic. We got to coin. We got to copyright this.
Could we get Toto in it? Well, Toto had the song Africa.
Yeah.
I don't. That's a little too far removed.
But. Wegener had evidence like, hey, there are fossils from this continent and on this continent that are ocean apart. There are glacial striations all pointing in the same direction from this continent to this continent. They're the same soil, the same elemental composition. Like he had the evidence. He just couldn't tell how they separate.
His mechanisms that he proposed, they're pretty interesting. He thought it was the centripetal force from the Earth spinning that was moving the plates around, and then some physicists did the back of the envelope calculations, and they're like, dude, you're off by like 1 million times. Like that's not even close.
He did tides too.
Yes.
Tidal force was
which is the same. I mean, that's tied in with that, but yeah.
Well, there are let's see, what's one of the moons? Is it one of Jupiter's moons? Actually has volcanic activity because the tidal force is so strong on that moon. Is it
really?
Yeah.
It basically keeps squishing it to the point where it's like heating it up just from basically from being squished by the gravity of Jupiter.
Oh, it like heats it up because it squishes it so much?
Yeah, don't quote me on this. We should look this up. I think it's Io.
It is.
Don't quote me. It is Io?
Here's a fun fact.
Woo, I was right.
That is my favorite moon.
Io's your favorite moon. Why?
Yeah.
Why would you say that?
I don't know. But once in like 3rd or 4th grade, as a project, I made a board game on a piece of poster board called "Where in the Universe is Io?"
Man, you really had to get out.
If either one of your parents are listening right now and they can happen to find this board game, I will gladly pay them for it.
Geez, there's insight into my childhood.
Just if you listen to the past episodes, the back catalog of the Flannelcast, Jesse throws out these tidbits about his childhood, and if you listen to one of the really, really early episodes where the quality was like really crappy, and not saying like our quality's great now, but Jesse said something about there was like a summer where it wasn't warm, where there was no summer.
Mount Pinatubo. I remember specifically.
Yes. Yeah, and so Jesse's brother emails me and says that's a bunch of BS. Like,
it was the summer of '92. Mount Pinatubo.
Your brother emailed me and said, "Nope, don't listen to Jesse.
We didn't go swimming all summer. We just played on in the backyard, on the street, up in the woods." And I'm sure my brother's listening to this episode. Long time listener.
Yeah. What's your brother's name?
Ryan.
Ryan. That's because I think he sent something into the Flannelcast website or something and was like basically saying like, my brother's full of crap. Don't listen to him.
But should we segue into what I am full of crap? The Dante's Peak.
Oh yes.
Oh, You got called out?
Well, I want to apologize because I was way off. I will admit to my errors.
Yeah, so this is Angela reached out to us on Facebook Messenger. And yeah, she called us out.
Yeah, because what I said was, I've seen the movie so many times, and there's a scene where, the Dante's Peak is named the second best city, population under 20,000, and they talk to the motel guy, and they're like, "What's number one?" And he's like, some piece of crap town in Wyoming. And I was like, "Oh, it's funny because the movie was filmed in Wyoming." I was totally off.
Idaho.
So the movie was filmed in Idaho, and the guy actually says is some piece of crap town in Montana.
Oh, it doesn't even say. So you're wrong on both ends.
Yeah.
Wow.
And I'm glad, Angela. Please keep us honest here. If we are spreading untruths about Hollywood fictional films.
Yes.
And
so,
which brings me to my next point. Thank you, Angela. And if
Angela,
you would like to be an intern here at the Flannelcast to be our fact checker
Ooh.
during the episodes.
Yes, we only charge $500 a semester for the credit.
It's a paid internship in that you pay us.
Yeah, exactly. Right? Isn't that how the good internships used to be?
Yeah.
To get the really high demand ones.
But honestly, if you hear something that doesn't, and shoot us an email. We like correcting ourselves as any good scientist should. You should.
Yeah.
Yeah. So thank you, Angela. I've been meaning to send you a message to apologize. I'm going to send you a message, and if you shoot us an address, we'll throw you some Flannelcast stickers.
There you go. Yeah. Thanks, Angela. You know how to get a hold of us. You called us out once. You can call us out again. But thank you. Yeah, and there are times when we talk about something where we're not 100% accurate. Think of this as like the intro to geology version of things. Like, because sometimes you have to say to students, like, well, that's not really the whole story, but for the gist of it, that's what you need to know.
That's an interesting point. We all have our own specialties, but yeah, when you teach an intro class, like you're teaching a survey of the entire course, and sometimes you just have to. You're giving them the basics, even though like there's nuances here, and so sometimes you're like, well, there's a lot more here. You can take a whole class on it. Take it if you want.
Yep. And I often say that a lot. Like you can have, you teach what a metamorphic rock is, and a metamorphic rock is a rock that was heated and squished to the point where the original rock is no longer there. Well, that's not always technically true, because you can have traces of the original rock still there, but you don't have time to digress and talk about how most of the rock is gone. Now, usually it's gone. You just don't have time, so you just kind of cut it out and say, like, "Yep, metamorphic rock." Get cooked and squished away the original version of the rock, and now you have this whole new rock.
Is there a difference?
Here we go.
Yeah.
Where is this going?
Is there a difference? And I often, when I teach igneous rocks or volcanoes, is there truly a difference between lava and magma? Is there like a chemistry difference?
Oh, it's a location thing.
Well, yeah, that's what I mean. Is it just semantics about location?
As far as I know, yes. One's above ground, one's underground.
Yeah, exactly.
That's it.
All right. Well, okay. That's all I needed to know. I wasn't sure if there was like a geochemistry thing going on or not, but yeah, it's just semantics then.
I guess.
You could say that lava's cooler, so it has a lower temperature. So there is a geochemistry thing going on there.
No, it doesn't have to be cooler.
It doesn't have to.
You would think that it gets spit up onto the surface. And so
No,
initially it's warmer, it's the same temperature, but then it would
initially.
And you could say that you can have magma for millions of years sitting around. You can have lava, lava only lasts what, hours at best?
Yeah, hour, maybe.
Yeah, but you think about like a lava at a hotspot versus magma at a subduction zone. Lava at a hotspot is hotter than magma at a subduction zone.
Well, that's actually
Ooh.
Here's where we go. Perfect segue here for a news story. There is.
You didn't answer the.
I just got. What would you say?
Doesn't matter.
I was more worried about my segue.
I just realized we had a news story about lava temperature with the new largest shield volcano on Earth.
What?
Yeah, it's underwater in Hawaii, and let me see.
Mauna Loa being replaced? Is that?
Yeah, it's not the biggest anymore.
Now here's the question: does Olympus Mons
I don't think. Okay, I don't actually want to say that on the air.
There's a gravitational.
Yeah, I was going to say exactly. Because
the physics of it.
Because how it works is like mountains on Earth are limited on how big they can get, right? Because the bigger they get, they'll just start sinking into the Earth. So, from my understanding,
the sinking is called isostasy.
Mm-hmm.
Where you have an isostatic balance, which we'll save for a different time and place.
So Mount Everest, from what I'm not an expert in this part of geology, but from my understanding, Mount Everest is pretty much as big as it's going to get.
Yeah.
It grows a few centimeters a year, but then it weathers.
But it's not going to get substantially larger, right? Because if it does grow larger, it's going to sink down more.
Yep. So Olympus Mons on Mars, for reference, is the tallest mountain in the solar system, as far as we know.
That we know of.
Yeah.
Did you say on Mars?
On Mars, yeah.
Okay. Yeah.
And it's like, I want to say it's 68 or 69,000 feet.
Wow.
And so, yeah, it's
and it's a shield volcano.
It's a shield volcano.
Mm-hmm.
Yeah. So it's I just did a quick. Yeah, it's 69,800 above datum, above local relief, which doesn't necessarily mean much. It's 85,000, which is, when we think of Mount Everest is 29,029 feet and going up a little bit. Why we say Mauna Loa, Mauna Loa on Hawaii's Big Island is only 14,000 feet above sea level, which is where we measure mountains from. But if you measure it from the sea floor where it's growing from, it's actually 33,000 feet. So it would be the tallest mountain on Earth.
If there were no ocean.
Yeah, if you were measuring it from the crust.
So
but we don't.
This new volcano, or the current now world's largest shield volcano, is let's see. It says that it is 148,000 cubic kilometers underneath the water, and Mauna Loa is 74,000.
Whoa!
So it's like, but here's the deal. I'm looking at this. It doesn't say if it's in cubic miles or cubic kilometers, because they but it looks like it's substantially larger than Mauna Loa.
Is it being fed from the Hawaii hotspot?
Yeah, they talk about the whole hotspot. And then the other interesting thing is that the lava that made up the shield volcano is the hottest they've ever seen. And let's see, they go into, it has like a huge amount of the mineral olivine in there. And they talked about, I believe it's, there's a couple different types of olivine. Olivine's a mineral. In most of it, usually you find it in the Earth's mantle. Sometimes some of this stuff makes it to the surface of the Earth. It's not really that stable at the surface of the Earth, but this has a lot of olivine in it. And
well, this sort of leads into like how we don't have a great understanding of how hotspots work. If they're fed from there's sort of competing theories about where the magma is actually generated.
Mm-hmm.
If it's deep in the mantle, we know that because it's so hot and you have olivine. But there's some thought that actually these plumes, these hotspot plumes, come from the core mantle boundary.
Mm-hmm.
So they come from really deep, which is sort of crazy when you think about it. When we think so hotspots you can think of like if you're unfamiliar, just pipes of magma that are unaffected by plate tectonics. So the magma just keeps coming to the surface and the plates
punches right through the middle of the plate.
The plates just slide right over them. If you look at a map and you see all the Hawaii islands, all of the islands except for the big island were formed by the hotspot, but they're no longer active. The plate just kept moving.
Mm-hmm.
Right. Yeah, and that composition, it's different than other volcanoes, and that's why they have this theory about the source of the magma is different than other volcanoes because the elemental composition of the lava coming up is so different than lava that's spitting out at plate boundaries.
So couple fun facts about this this volcano. Let's see. They said the magma that makes up this volcano is 1,703 degrees Celsius. And so if you're in America, that's 3,097 degrees Fahrenheit.
Crazy.
And it's the hottest Hawaiian basalt that they've ever seen. So basalt is the rock it's the rock that makes up the majority of Hawaii in these volcanoes. So this stuff's really, really super hot, and it's the highest concentration of this mineral called phosphorite, which if you're not a geologist, it's a type of this mineral called olivine. Like I said, it comes from the Earth's mantle. And it's just the highest concentration of the stuff that they've ever seen.
So if you are into minerals, and I'll just go over this for literally 20 seconds because I'm not a big mineral person, but olivine comes in, it's a spectrum coming from olivine is made of silica, and it's a spectrum if it's got iron in it to magnesium in it. And if it's iron rich, it's called phalite, and if it's magnesium rich, it's called phosphorite. And so you can sort of tell how deep it comes from based on that proportion of sort of iron to magnesium. That's how they're saying like maybe this is coming from deeper or less deep, and so on and so forth.
Yeah, so this is super magnesium rich.
That's interesting. I mean, yeah, it's pretty interesting.
So the name of this volcano is, I'm going to butcher it because it's my native Hawaiian is not up to par, but I want to give it a shot. Puhahanu is the name of this new volcano.
Oh, what does it mean? Do you have a translation?
Why are you doing this?
Sorry.
No, I don't know. I don't know what it means.
Well, you really let me down.
Well, it's not the first time, and it won't be the last time.
It means island yet to come.
Oh.
No,
really?
I just made that up. No.
Oh, come on.
You say it with confidence like that, and then we'll get a Facebook message saying I was totally wrong.
Yeah. Thanks, Steve. Don't listen to Steve, all right?
It sounded good. I had you believe in it.
Oh, it means here, puhahanu is a Hawaiian word for turtle rising for breath.
Oh, yeah, because it's just peaking above the water right now.
Well, it's still underwater. Yeah.
There's what I'm seeing, like, just as of, like, Monday. Today.
Well, yeah.
Monday, May 25th.
Happy Memorial Day.
Yeah. What I'm peering at.
Oh, yeah. Okay. Yeah. So it's just breaking the water now, right?
Holy moly, 3,000 degrees Fahrenheit.
That's what I just said that.
I know, but I
like wrapping your head around it. Yeah. Cook a steak like that.
Yeah. I was about to say, like, I only half listened to you, But that's
Won't
it.
be the first time, won't be the last time, ladies and gentlemen.
If you're watching the video on YouTube, that was during the part where like you just saw me scoot out of scene.
Yeah.
Yeah. That's really cool. Huh.
Yeah.
So, I think it's when we were talking about like Mount Everest and these mountains, they can only grow so tall. We should maybe just mention the story about the surveyors. I don't even know if it's a real story or if it's just apocryphal, but it's a great story, and it's a story I feel like we all repeat in our classes about
the original English surveyors when they colonized India.
Yeah.
Go ahead.
So, as Steve, were you saying about the mountains sink into the crust as they get bigger? I don't know.
Yeah. Well, yeah.
Yeah, one of you jokers.
We were all.
I think we were all shouting at the same time.
Mm-hmm.
That sounds about right.
So one of the reasons, there's this, the gravity influences how big mountains can grow, essentially, I guess, in a very simplistic way of thinking about it. And so mountains on Earth, as Chris was saying, could only grow so large. Mount Everest is sort of maxing out, 30,000, a little bit above is probably it. But it used to be thought that mountains sort of sit at the surface and like they're crumpled crust from convergent boundaries, and they grow upward. And it was thought like, all right, there's the surface and then the mountains grow upward. And some surveyors in, I guess, the mid 19th century, after there's a long sordid history about the English crown taking over from the East India Company in the mid 1800s, taking over basically India. And they surveyed that. One of the first things they did was they were surveying things, and they went up to Nepal and they were surveying the Himalayas. And so what they started realizing when they were their survey equipment, one of the things they use is a plumb bob, which is just essentially a string with a weight on the end of it, and it gives you basically a straight line, a normal line to the surface. And they started going around these mountains, and they were surveying things, and they realized that their lines were off. That essentially what was happening was the mountains were just in a very minor sense, pulling the weight towards them.
So the plumb bob was like a really elementary gravitometer?
Yeah, essentially. Yeah, and it's been around, like the ancient Egyptians used it. It's been around for a long time because it works, because of gravity. No one's touching gravity. And no one messed around with gravity since Einstein.
Used to use plumb bobs to hang wallpaper back in the day. Had a summer job. Yeah, hated it.
Yeah. Oh man, wallpaper's the worst.
It really is. I remember thinking in the 90s, like, who does this anymore?
Yeah. When I was a kid and we moved into this house when I was young, and it had all of this wallpaper from the late 1800s that we pulled off. And then I remember like hanging new wallpaper with like my mom and my grandfather, and we had all of this equipment to do it. And I remember thinking like, this seems like a lot of work for what it's cracked up to be.
Yes.
And then like later on, like growing up, we ended up ripping it all off and just painting the walls. And I remember thinking like, this looks a lot nicer then, and there's a lot less involved. And then like when my parents retired and moved, had all this like wallpaper, I was like, what do we do? And my mom was like, does anyone want these rollers and this 12-foot long table to lay out wallpaper? And we're like, no, we're good. But anyhow, so they had this.
Sorry, back to the survey.
No, they had this plumb bob, and so what they realized when they're doing the calculations is that the string and the weight was actually being pulled towards the mountain. And when you can do you can do the calculation.
I didn't hear this part of the story. This is new to me.
So you can do, and it's like fractions of a fraction of an inch, but they were being very precise, and so they figured it out. And what you do is when you measure like the area and the height of the mountain, the mass doesn't make sense to produce a gravitational effect that they were seeing.
Yeah, that's got to be a big amount of mass.
The only way that you can account for it is if the mountain has what they called a root, which is like this mass that actually extended below the surface. And so the mountain itself, what they realized wasn't just the surface up, it actually had like a quarter to a half of the mass below the surface.
Wow. Yeah, it's I always tell people, like, when you think about mountains, you kind of picture them like icebergs. Like whatever you see above the water is what is like 10% or whatever of the iceberg. Like 90% of it is below the water.
Yeah.
Now I don't know if it's the same ratio for mountains.
No, it's not the same ratio, but yeah.
But you can kind of think of it like, it's kind of a metaphor for for mountains.
The way I explain it too is like if you sit on a couch cushion, the couch cushion is flat, and then you put all your mass on it. You're not just sitting on the couch cushion flat and you're everything above, you sink into it a little bit.
Yeah, that's a good one.
You're,
always think of the root of Mount Everest as Jesse's bottom.
Just
there you go.
And then you stand up and the couch cushion rebounds.
Ooh, isostatic rebound.
Yeah.
We'll save that for another podcast.
Yeah, it's a different time, different point.
Well, I got another story to add on to your story, Jesse.
Yeah.
So these surveyors, the English surveyors, they surveyed the summit of Mount Everest. So right now we know the elevation of Mount Everest is 29,029 feet above sea level. All right. So these surveyors in the 1800s they were doing this, Jesse?
Yeah, 1850s, I think.
Okay. So whatever. Before all the before computers, right, and all this microprocessors.
Slightly.
Okay.
Slightly. All right. So these guys surveyed out the summit of Mount Everest to be 29,000 feet exactly. And so they were only off by 29 feet.
Oh,
from
weak.
Well, they accounted for. No, that's not weak at all. It's amazing that they did that. They accounted for distortions, like visual distortions in the atmosphere and everything. And basically, these guys are just using trigonometry just to survey the summit of Mount Everest, and they are only off by 29 feet, which is like, I think that's amazing.
I would say go back and do it again.
Yeah. What always blows my mind
is they did do it again. All right. They
oh.
Yeah. Okay.
It came out. They figured it was 29,000 feet, like to the dot, and they said, well, we can't send this home on our final report. They're going to think that we're a bunch of slackers. Like 29. Yeah. Really, what are the chances of this mountain being exactly 29,000 feet tall? So they put like some like weird number, like 29,003 feet. They purposely were wrong. They made it a little bit off, just so that their number would be more believable and people would actually be confident in their findings.
No, I always find it amazing that they can, like, you have to put that to some sort of datum, which is sea level. Mm-hmm. And how do you know what sea level is in 1850 when you're in Nepal? Like,
you don't have Facebook and you don't have Game of Thrones.
No, but
there's nothing to do.
But essentially, they had to, like, step by step from the sea, go step by step all the way to Nepal, putting in benchmarks and analyzing things from there. And it's like the fact that they were off by 20 feet, Jesse, I'm okay with 29 feet, I guess.
Yeah, no, I'm just.
No, that's
Yeah, no,
I'm with you though. 29,000 on the dot. You lied to me.
They're also like doing this in like 3-piece suits.
No, it turns out that was all a myth. They just put the 3-piece suits on for the photos.
Wait, really?
No.
Jeez.
I was afraid I was going to crush your world if I.
Wow.
There's occasions where I'm like, I should be dressed up more than my shirt that literally says geologist. Yeah.
Go Birds.
It is. It's pretty incredible.
I am wearing my flannel. It is hot, but I'm wearing it.
It is. Yeah, it's
Because
tough.
professionalism means something to me, gentlemen.
Shoot.
I'm not wearing a flannel right now. It's
Yeah,
like it was like 90 down here today.
Yeah, sorry, Liz. Our
Yeah.
longtime fan who keeps calling us out.
But it works on me. I keep wearing it. Actually, it was on the back of my chair for like 6 days, and I washed it yesterday.
Yeah, I was just looking around because I'm next to my laundry here, and I don't see anything. It was hot today. The sun poked through.
Yeah, when the sun poked through, it actually got warm. But I think tomorrow is supposed to be even hotter, like 8 degrees warmer.
We're gonna be pushing 80. Don't care for it.
I'm not ready for that yet. I mean, I guess it is almost June, but still.
Yeah.
All right. Anywho,
well, I can use this as a segue for a story I saw. Warm weather. Guess what?
Question mark?
What?
So some long-term data by some researchers out of the University of Wisconsin-Madison. So there's a NOAA scientist based out of UW-Madison who looked at a bunch of data, and surprise, surprise, hurricanes are getting stronger.
What?
And so this is really funny because funny in a sad sense that, things are getting worse. I just taught a climate lecture to end my semester 3 or 4 weeks ago. And I just offhand, I was like, what are the effects we're going to see? We're going to see ocean effects, right? So like it's going to shift the way, if increased temperatures are going to shift the way climate works in different areas. You have habitat effects, coral effects, and obviously melting land ice gives you sea level rise, and thermal expansion is 1/3 of all sea level rise. But what about hurricanes? And I was like, there's kind of an unknown with hurricanes. Are we going to see stronger storms? Are we going to see more storms? For a long time, there was thought that we'd see a lot more storms, and that doesn't necessarily seem to be the case. And I just did some really quick. I was like, I'm just going to look it up really quick here. And I was like sort of on the fly during my Zoom lecture. And I was like, this is interesting. From 1960 to 1999, so basically 40 years, we had 54 what I said major hurricanes, so category 4 or 5. I got rid of category 3. Doesn't count. So
it's not major.
It technically is, but I didn't.
Oh, this is you're doing this.
Yeah, technically 3, 4, and 5 are major hurricanes.
Okay.
When you hear that term, a major hurricane, there's a technical definition.
What's the requirement? Let me look up. While you're doing this, I'm gonna look at the requirement of a category 3, 4, and 5. I should know this, but
yeah, you should. 111, 124, I should know this too.
What is it? Is 74? Is that
all right? A category 1 is
Simpson Saffir scale.
Saffir Simpson, yes. So category 1 is 74 to 95 miles per hour, or 119 to 153 kilometers per hour for our international, our listeners in Ireland, because we're
like the number 27 science podcast in Ireland.
If you say it enough. Oh yeah, so they're saying 3 is major. Okay, so all right. Anyways,
I'm not making enough.
2 is 96 to 110 miles per hour. Shut up, Jesse.
Oh, what I say?
I like that you fact check Jesse, even though he usually spouts out facts, and then I say something ridiculously off the wall, and you're both like, okay, yeah.
Yeah, 111 is a category 3.
111, yeah. So, category 2 for international audience, 154 to 177 kilometers per hour. 3 is 111 to 129 miles per hour, or 178 to 208 kilometers per hour. A 4 is
130.
Oh crap! Here it is. Sorry, I almost clicked out of it. 130 to 156 miles per hour, or 209 to 251 kilometers, and then a 5 is 157 miles per hour or higher, or 200.
Yeah, so there's been talk about, like, should we have a category 6? Because the past
but how many hurricanes have breached? Like what? Oh, I don't know. Go ahead. Go ahead.
And honestly, is the devastation from the wind or is it from the water? Should we just be measuring these things based on how much water was discharged?
Well, it's kind of like the wind causes the storm surge, and then That's
First off, we base categories on a 3-minute wind gust, the 3-minute sustained wind velocity.
Yes.
So, yes, storm surge is based on. There are some people who say like we should measure it on low pressure, which tells you how organized the system is.
and we just recently had the lowest low pressure hurricane ever recorded within the last couple of years, right?
Yeah, it was hurricane. It hit Texas.
Oh, is that the one that just sat over top of Texas and dumped all that water on it?
No. It was sorry,
Wilma in 2005.
Yes, Typhoon Tip. Lowest in the world
for the international audience.
Yeah, but yeah, Wilma, which I think hit the Texas coast. But yeah, because the thing about Category 6 would be the past couple of years we've had a bunch of hurricanes like Maria and others that were like 185, sitting at 185, 195, 200 miles an hour. We had not seen that in a really long time. The last hurricane Category 5 until the past like 3 years was Andrew in the 90s, I want to say. So it's
Katrina was a 5 when it was out at sea.
When it was out at sea, but when
it didn't hit New Orleans.
But we don't care about that.
Yeah, hit land at what, a 1 or a 2?
2, I think.
2 or 3.
I think it was a 3. Yeah, it started slow.
I was saying a Sandy. Sandy hit.
Sandy hit wasn't even a 1.
Sandy was a 1, I think. The reason that Sandy was so bad is because it took that sharp. It just turned like a 90-degree angle to the west.
The hurricane shouldn't turn left in the northern hemisphere.
Or to the west. It doesn't. You can't say to the left.
I'm in the northern hemisphere and I'm looking up.
Yeah,
I'm looking up, and everything.
That was the whole thing. The reason that it was. When it made that westerly sharp turn and it hit the eye of the hurricane, hit over Atlantic City, New Jersey, and everything north of Atlantic City just got walloped because the way that the low pressure system spins north of Atlantic City or north of where the eye hit the landfall, the wind was going landward, and the wind was acting essentially like a bulldozer, and that's what caused the storm surge, and it was shoving all of that water onto the land, and that's why it was so bad. For
the storms spin counterclockwise. That's why
in the northern hemisphere.
Yeah, in the northern hemisphere. Plus, it was high tide,
and it was like a full moon too.
Yeah. It was a full moon at high tide. It was like all of the. So anyway, from 1960 to 1999, 40 years. Category 4 and 5, we've had 54 major or 54 4 and
4 or 5s. Yeah.
From 2000 to 1999, so half that time, 20 years, we've had 56 Category 4 and 5s. So in the past 20 years, we've had more Category 4 and 5 storms than the previous 40 years, and so that's basically what this researcher is also saying. He obviously did a lot more work than me just going to the NOAA website and pulling up database data, but we came to the same conclusion. So
yeah, and it's
probably should be co-author.
From 1960 to 1999, like 1960, there was reliable data. It's not like you're saying from 1750 to 1950 there was this many.
Yeah, and now part of it's one thing to say like this is what happened. Another thing is to look at it and say, all right, not all of these storms hit land, right? Mm-hmm. So they weren't all like devastating, but at the same time, they're stronger. Like we've had stronger we've had cumulatively stronger. Whatever. We've had more storms that are
strong,
windy.
You're getting windier. The wind speed is increasing. Is that what you meant to say?
I don't know.
No, we've had. There is a more of a. Why is it so hard to say? There's an accumulation of more powerful storms in the last 20 years than there were in the previous 40 years.
And so, part of this is hurricanes are driven by warm water. And so, this is probably because the world is heating up. The ocean is absorbing a lot of our
Excess heat.
Yeah. And so how that affects these hurricanes.
So we should just
sort
dump
of
a bunch
big
of
unknown.
dry ice in the ocean.
I'm not
Right?
asking for much.
Yeah. How can we just add a little more carbon dioxide to the system, but it's cold carbon dioxide. So
there is, I know, there was a study. Some people were trying to look at seeding the ocean with iron.
That's a terrible idea.
And because of these algal blooms, and they found the one limiting nutritional factor in these algal blooms is iron, and that's all they need. And these algal blooms get iron from the dust or the sandstorms coming off of the Sahara, blowing westward into the Atlantic Ocean, and that falls into the Atlantic Ocean. And that's the source of iron, and poof, it goes up. And so there's a thought process. There's an article in Nature or Science, I forget, one of the big guys, either Science or Nature, and there's talking about if all we got to do is just dump iron pellets, and that's it, and then you get these blooms, and the hopes is that it will absorb carbon essentially into the ocean, but well, not into the ocean. That's not right, but through photosynthesis, and the algal blooms taking in carbon dioxide, releasing oxygen. But then there was a fear that what if we do this, if we do ramp up this iron dumping into the ocean, what if it goes too far and then we accidentally push ourselves into an ice age? Whoopsies. So
there's some thought too that if you have too much algal productivity, you can make that area anoxic. Because these things,
I was just going to say, doesn't that kill everything?
When they die, yeah. Well, it's the decomposition when it dies. Like as long as they're alive, right? It's
no, but the algae itself eats up so much oxygen that it kills everything else.
Yeah, well, they're not doing it, so.
All I know about geoengineering is partially based on The Simpsons. And partially based on truth when they released frogs into Australia.
Yes.
So all I know is that every time we've ever tried to geoengineer anything as humans, it has turned out poorly.
Yeah, there's always unintended consequences.
Geoengineering or terraforming? I mean,
both.
I guess, yeah, both.
If anyone has an example where it worked, let me know. Be happy to know.
Shoot us an email at questions@geologyflannelcast.com.
There you go.
All right. Do we have anything else here? What do we got?
Let's move on to the next one. What do you want? We got a couple other stories. Which one do you want to go for, Jesse? Steve, what do you want to go for?
Do you want to do the magnetic field or do you want to do rock samples?
I feel like we spent a lot of time on the rock samples. So let's hold off on that let's do the magnetic field real fast.
Okay.
So I'm going to pull the story up. So in case there's any listeners out there that are not aware of this, the Earth's magnetic north is not the same thing as the Earth's geographic north. So,
what?
I know. So if you're trying to find Santa Claus and you have a cheapo compass that you got at Walmart, that's not going to take you to Santa Claus's house where all the elves are. I'm sorry. It's going to take you to...
Well, how do you know that? Does Santa live at magnetic north?
I assume it's geographic north because you always see around Christmas time, you see him next to the North Pole and it's candy striped like a...
I've never thought about it before. Is it
cane.
Magnetic north or is it geographic north? I never really thought.
I mean, Saint Nick needs to get his ish together, man. Where are you at, man?
Well, maybe that needs a boat now. But
yeah, you might be have a good point there. So the magnetic North Pole has been over northern Canada for a while, but what happened recently is this thing's been hauling butt and it's been moving like really, really fast. And it's getting closer to Siberia now. And so there's a study that was recently came out in Nature Geoscience And the researchers believe that there are, well, I guess before I get into the findings, we should talk about real fast how the Earth's magnetic field works. Okay, so you go inside the Earth, right? So you got the crust, that's the outer part of the Earth, obviously. And you move down, and then you hit the Earth's mantle, that's the biggest part of the inside of the Earth. And then the next layer down is you have the inner core and the outer core. All right, so everything on the inside of the Earth is solid except for the Earth's outer core. All right, that's liquid iron and nickel, molten iron and nickel. Right, and so there's convection currents going on inside the outer core, and these convection currents of liquid iron and nickel cause something called a dynamo effect, and that's what essentially drives. That's why we have a magnetic field on Earth. All right, so that's what's driving everything, and there are researchers have found in this that there's these two massive blobs of molten iron inside the Earth's outer core that may have spurred this kind of like runaway pole effect that we're seeing, and it's moving really, really fast. There's a let's see. So the Earth's magnetic, or there's an organization that they release because it moves around. It's called Polar Wander.
A lot of, and this is just a segue here. A lot of not segue, but add on. A lot of early Arctic researchers, like 19th century explorers, the Franklin expedition, and others to the South Pole as well. One of the things they were doing was looking at the magnetic field of the Earth and trying to get a better sense of, they were setting up magnetic stations and trying to understand where the magnetic field was strongest, because that affects how your compass. So if you've ever had a map and you have a compass, and the compass points to north, that would not take you to the North Pole. That would take you to Canada. And so you have to account for that, and that's called declination. Mm-hmm. So a lot of these early explorers were trying to understand this effect of polar wander and declination and things like that. Mm-hmm. So anyhow.
Well, so like normally the Earth's magnetic pole might shift around like 9 miles per year. But they've been seeing it recently move as much as 37 miles in a year.
Holy cow.
And so, this thing's like hauling butt. So it's moving towards Siberia, and so it's just they had to. There's a group that let's see. In 2017, the magnetic North Pole fell within 240 miles of the geographic North Pole. So that means in 2017 it actually was pretty close to the where the geographic north is, but it's still kind of moving around. And like I said, now it's getting closer to Siberia. So that's that with what's going on with the Earth's North Pole. That is
crazy. And let's face it, most of us don't need to worry about that anymore because computers and a lot of apps and stuff take into account declination. But if you are doing some precise mapping and things like that, you can actually look up what the declination is for that day. Like you can get it that precise.
Yeah, it's pretty crazy.
Yeah, because some maps are printed like 20 years ago and they'll have declination on it, but you should actually go check it because like Chris said, it can move a lot.
So there's a group out there that does they come up with maps every year, like the navigational maps where the Earth's magnetic north is, and they actually had to release a new map much earlier than they would have normally had to because this thing's moving so fast. And this shift to the magnetic north, it's a big thing for any type of navigation. So it's anything that uses a compass. So
yeah, and a lot of things now just use GPS, so they're just based off of satellites. But then those satellites need to know where they are in position and time and things like that. So it is important. Mm-hmm. But for everyday users, no, nobody notices.
Well, yeah, you wouldn't notice unless you're. There's let's see. There's some I guess I don't know if it's a hypothesis or if there's more evidence of it, but people there's stories about in birds they have magnetite in their brain, and people feel that that's like one of the ways the birds hone into the Earth's magnetic fields and they know how to migrate, which direct in the summer and winter.
Yeah, that would be interesting to see if the years that it does speed up, do migration patterns change?
Yeah.
So you need some geophysicists and some biologists to team up and figure this out.
Yeah.
And then see if they can drop little iron pellets on their way into the ocean.
There we go.
Fix
Full
climate
circle.
change.
Full circle.
Yeah.
So, there you go. Fun story.
So one of the unknowns in life is why the magnetic field flips every now and then.
I was going to go into. I didn't know if we should go into that, but yeah.
Let's throw it out there real quick.
Yeah.
And so one of the thoughts is, so the inner core of the Earth is solid, right? It's solid iron and some nickel, and the outer core is molten, and like Chris was saying, creates this dynamo. So the inner core is getting bigger. It's crystallizing because the Earth is cooling off. There's some thought that the inner core is actually not a perfect sphere. It's a little bit lopsided. It's crystallizing on one side preferentially as it rotates, because it's rotating like the Earth is rotating. Because of relativity, the core, if you've been standing on the core, you're actually younger than if you were on the surface. Yeah, because it's spinning because of gravity, because of the mass. It's actually like 2 years younger than the Earth or something crazy. But there's some thought that every once in a while, because it keeps preferentially adding to one side, it just sort of flops over. It changes its rotation, and that flips the entire magnetic field. I don't know much more beyond.
We did do, back in the day, years ago, we did an episode about, or one of the news stories about how, I don't ever know, I didn't really keep up on it, but there was an article that came out, and they said that they discovered 2 more layers inside the Earth's inner core. There was the outer inner core and the inner core.
Yeah, I do remember talking about this. Yeah.
So but I haven't heard anything about that ever since then.
No, but one thing they did just come out with back in April, there was a paper about this. They found, or at least they're hypothesizing, that heavier iron isotopes are escaping the core into the mantle, and
escaping the core. Okay.
Yeah, so
wouldn't that
heavier iron isotopes are leaving the mantle, or leaving the core, and into the mantle, while lighter iron isotopes basically circulate back into the core itself.
I would think it'd be the other way around.
No, you can't think of it like evaporation, like the ocean. You got to think of it like centripetal force, like the heavier stuff's getting thrown out first.
Yeah. So it's.
But isn't that how, like,
computer simulation too?
Isn't that one of the reasons, like, how basically differentiation works in the Earth? Like, the lighter stuff eventually goes to the out. Like, that's why
everything is molten and things are solidifying. This is basically looking at temperature and pressure, and
and differentiation. Doesn't that happen too before the Earth really starts spinning?
Great question.
I'm not even going to comment. That is so far above my pay grade.
Yeah.
What do you want the answer to be, people?
Yeah,
I don't know. I have no idea.
No, but we did do a podcast on, plate tectonics and the dynamo and the magnetic striping on the, like, who was that? Hess, who.
I think that was that our first episode?
I think that was our first episode.
Oh.
And it was like the anniversary for when what's his name? Charles Hess, was that Charles? It doesn't matter. Hess.
Harry,
Yeah.
Harry
Yeah.
Hess.
Harry
Hess.
Hess. Harry
That's
From,
it.
Hess. Yeah,
from
that's it.
Princeton.
Yeah.
Yeah.
Just across the river there. So, well,
That was back in the day, man. That
Yeah.
was
the 40s, right?
Oh, I think when the first episode, our first podcast
Oh,
episode.
no, that was in the teens. We're now in the 20s.
Yeah.
So,
Different decade, baby.
yeah. Well, we'll have to revisit it. We'll have to revisit some of our old gyms and spruce them up. You know,
Yeah.
plate tectonics is real now. It wasn't back in 2014.
No, it was. I don't. We don't need any more people messaging in saying that. I'm pretty sure plate tectonics was pretty well accepted in 2014.
Yeah, but anyway, that's all I have,
All right.
which is basically nothing for this week. Sorry.
Well, we got
go ahead.
we got another story still.
Oh, I'm sorry.
Yeah, we don't worry, Steve.
I'm sorry.
We are a well-oiled machine
I thought you said you were saving that other story for another time.
for right now.
Well, I stand corrected.
Why don't we let's punt this one off to Jesse. Let him cover this because I think he's got some I think he's got a couple things to say about this. I think we all do.
Is this the one about rock samples?
Yeah, the Washington Post one.
Yeah, so it was actually a really good. It's an opinion piece,
Mm-hmm.
and it's about how rock samples aren't. So the gist of the article is that you have all these researchers that go out and they look at rocks, as we do, and they don't archive any of the rocks they have, or they don't share them. And so part of the idea of being a good scientist is that your work needs to be reproducible.
Mm-hmm.
Mm-hmm.
So you make a claim and someone says, all right, well, I want to test that claim to see if I can also come to that conclusion. And if you make that claim off some rock or some sample, and then you don't share it, or the person has no access to it, it makes it tough to reproduce it. And it's a problem apparently in geology where, especially if sites are sort of limited, or locations and rocks are limited and maybe tough to get to, people can't reproduce your results. And it's something we're sort of dealing with. There was an editorial in Nature about this, about making a case to share rocks and share samples. So I don't know, it's just an interesting way that, some of the, it's one of these things that's applicable to geology, because it's true. Like, we go out to sites and we go out to outcrops or whatnot, and we look at what we see and we take notes and but we also take samples and we take them back to our labs and we analyze them. And, how willing would you be to give up samples to someone who was just like, hey, can I have that? Can I borrow a piece of that rock to also do research on it? Well, it's applicable across all fields of science.
Yes. I was just going to say, like, geology is one of those sciences where you still can go outside, look at something, describe it, and be the first one to do it and reproduce it. And yeah, some of it is sweat equity. Like, you're going out, you're finding, like, if it was easy, somebody else would have already done it. So you have to go and find these places that either nobody else can find or weren't accessible before, and now they are. Whereas, like, if you're in physics or chemistry or biology or something, that's more technique based. Like, oh, everybody usually did it this way. I tried it a little differently and then did this first and then this second. And then you write a paper and you say, this is how I did it. I did it X, Y, and Z. And then someone can go back and try it X, Y, and Z. Whereas we're saying, no, I had to hike 20 miles in the hot sun to find this one outcrop. And I took my samples and I grinded them up and I analyzed them and came up with this hypothesis. And you know, if, and I understand there are some spots where it's just like, well, only Jesse Thornburg has access to this property and nobody else can go on this property.
Thank you. That's all I'm asking.
Those situations are like, okay, that stinks. But if you're doing something groundbreaking research too, you know, if I'm the publishers of this paper, it'd be like, I don't know, can you say like give access to someone else, or I don't know. I don't know what the answer is.
Chris can elaborate. Normally you would put where you got it from, or you drop a GPS.
Right.
So someone
you
else
can do stuff like that. Geez, you know, the first thing that comes to my mind kind of discussing this article is, you know, some of the stuff, if you have rock cores, where are you going to store it? You know, there's a big issue, you know, of just housing. And I there are like some things like some bigger, I know like the IODP, what's that, the Ocean Drilling Project or whatever.
Yeah.
They have their repository at Texas Tech, I think. I forget.
Well, so it's all over. So Rutgers has
oh, that's right. Yeah.
repository, and so I've worked with a lot of core, and part of when you pull up a core either on land or in the ocean, like, and I've been on drill sites where we do this, like you split the core in half instantly, and like you describe it, and the people who are on site are the people who have put in to drill this core. They've had a reason to say like, this is why I want to drill a core here. So it's almost like they have first dibs where they can sample, but they sample from one half of the core, and the whole second half of the core that's split in half is purely for archive. If someone else wants to sample to reproduce whatever because there's a moratorium before you can sample the archive.
Yeah, I think they have. If you like from this one organization, if you're on the team that collected the cores, I think you have like, what, 2 years, or there's like
a couple of years. Yeah,
the clock's ticking. It's not, you can't just sit on this stuff forever.
Yeah.
So, no, and it is. I've been on drill sites too, where there are some fossils, microfossils especially, that instantly start to decay.
Yeah.
So if you take them when they're fresh, you may have, I don't know, say 100 samples in a thimble.
I didn't even think about that.
But then if you wait 2 years and then resample it, there may be zero because they've either oxidized or just the pH changed.
You know, or the other thing that I was thinking about with this article, there's a couple things I want to talk about, but let's look at biology. Like, you know, what are you going to, like, so say that you're testing like a pharmaceutical drug. Are you saving like the blood samples from the people and like, so that other places can resample the blood? And I don't think it's necessarily a geology problem. And I know that they found this problem. It's a huge problem in biology, especially in the medical sciences, with reproducibility between studies. So with the one thing that jumped out at me was this article said, I'm just going to read it right now. Let's see, oh geez, I lost my place. Of course, right? Oh, here it is. I'm sorry. In 2015, a group of 269 authors attempted to reproduce experiments published in, they're called psychology journals, and only 39% of those people were able to independently reproduce those findings. So they are talking, it's not just necessarily a geology problem, but it's also like they mentioned psychology.
Okay, but I have a question. If I'm an expert in my field and I did X, Y, and Z, what are the odds that someone else can reproduce this? Like, I guess if you are like, you know, let's say I'm a super duper geophysicist and I came up with this theory based on magnetism in a rock sample that I collected. How many other people out there can actually do it? Actually have the tools to reproduce it? Maybe it's only 39%.
Yeah, geology is tricky. It's I know, and I think that from my personal experience, I think for the natural sciences, geology's it's a smaller field. it definitely doesn't get the press that like, something like, like particle physics would get, with their,
Yeah.
you
You know how many times I'm at a cocktail party and particle physics keeps coming up and nobody wants to talk about rocks? Too many times, Chris.
No, but I just think geology is a smaller field, and I know from my research, the stuff that I look at is such a kind of like a niche field. There's really not that many other people. There's only a handful of other people that are kind of doing the same thing that I'm doing, and then specifically, there's there's just not that many people, and so I mean, personally, I've never been asked for samples or anything like that. If anyone ever asked me for samples that I had archived, yeah, sure. But I can tell you this much, like stuff that I had from like my dissertation, I had a crap ton of sediment cores. I ended up throwing them out. I don't have room.
Yeah.
I just
anyone who's ever been to grad school for geology knows that there's like some filing cabinet somewhere like, oh, that's so-and-so's rock samples from 12 years ago. He said to not touch them. Well,
yeah.
At some point, you got to get rid of them. And don't get me wrong. I still have a drawer with my name on it in the rock lab at Temple University.
Oh, yeah, we have a drawer with both our names on it.
Yeah, exactly. So someone actually called me out like, do you still use that drawer? But yeah, don't touch anything in there.
Yeah.
I haven't looked in there in like 2 years.
So, okay, I got a controversial topic to bring up with you guys.
Oh, no.
Here we go. Asking the real questions here.
Oh, no.
I mean, my opinion is that part of the reason that we have this problem with reproducibility in studies is the pressure that we have on academics to continue to push out a lot of research in a short amount of time.
There is that, but there's always been that.
Yeah.
You think it's getting worse now?
I mean, personally, yeah. But I mean, I don't know what it was like, I mean, I guess, so I don't know what it was like 30 years ago out in the field, but it just seems like you have this pressure, you have all these people, you're up for tenure and you got to publish, and you got to get stuff out. And it's, I mean, I've never compromised any of my research, but I can see how there could be people out there that could, put stuff out that they're kind of like, a little arm wavy. And that's the other thing too. Sometimes you put out, some of these bigger journals like Science and Nature will put out kind of this like arm wavy, purposely controversial stuff, and they do it to get a rise out of people,
Mm-hmm.
And it's, once again, it's like that clickbait mentality. Now, I don't know how prevalent it is. And I'm sure, like, I'm not saying that anybody's research was compromised, but, I think at the end of the day, these journal articles, they do want to see these topics that will, kind of get people to notice.
We talked about this a little bit with Tim last week. Like, certain fields, this has been an ongoing thing for 100 years, where in paleontology, and there was a recent article about the KT extinction where like paleontologists will pay for access to sites that have fossils and only they can access.
Yeah.
And so there's a lot of questions about, you get into some really sticky ethics there, where if you're not letting anyone else in to sample those.
Right, to test that hypothesis, then if it's
not
not
repeatable.
repeatable.
There's some thought that like, well, after it's been excavated and curated, you can have access to the specimens. But it's not really the same thing, is it? To
No.
necessarily be at the actual site, especially when it's something that, if you're saying it's in situ in the rock,
Yeah.
versus you're giving someone a sample later on, or a piece of a sample. It is very tricky, and it's tricky when you deal with, like, if you deal with core sample or things like that are A, expensive to extract, and B, there's very little of it. Who do you give it to, or who gets access to it?
Yeah.
And
And it's expensive to store it.
Yeah.
Like
Yeah.
space is valuable.
That was my whole thing. So if you continue to do your research throughout a career, you start running out of room. I don't have room to store samples in my lab.
Yeah, I mean, I still have a whole lane cabinet full of like meticulously color coded, like labeled samples from all across the city of Philadelphia with soil samples, because I took all that time. I made sure that I had room to store it, but I know at some point I'm going to get the boot because somebody else is going to need that space. And then what do I do? I just have, to me, it's a budding research project. To somebody else, it's a 5-gallon bucket full of dirt.
There is a story that I'm not going to name any names. I'm going to be very, very purposely ambiguous with this, but someone was doing their research, their PhD dissertation project, and they collected all these sediment cores from this like really like interesting spot that a lot of geologists were interested in. Access was kind of a pain in the butt to get there, but this person went out there, they collected all these sediment cores, got into a giant fight with their dissertation advisor, basically said like, goodbye, see you later, took all their cores with them. And it was just like, go get them again. I'm done. You're not getting these cores at all. And I shouldn't have said this person just, we don't know whatever happened with those cores, but it was just like, oh man, that'd be awesome if we could have gotten those cores, but
they just disappeared.
I don't even know. I don't know. I never met this person.
I've heard this story of somebody collecting, was it limestone or sand or some like white sediment samples from South America, and then going through customs with all these vials of white powder and then getting stopped at customs, and you need to come with us, and the scientist being very nervous is like, no, it's just sediment, it's just sand, it's like there's nothing, I swear there's nothing. And meticulously took all these samples and had them all in glass vials and labeled and everything, and then they're like, okay, you're right, it was just sand. And he comes back into the room, they had just taken everything and poured it onto a table, so all the samples got mixed up. And
I think I heard this story. Let's talk off air who that was.
yeah, exactly.
I told you that story.
Yeah.
Oh, okay. Yeah, so that is okay. I know that. Yeah.
Yep. Yeah, I think I heard that story live from the horse's mouth.
Yeah.
But
yeah.
Well, there's another thing too. If you're importing sediment samples, always say that it's sediment. Never say that it's soil, because that's like if you're coming into the United States, you cannot say that you're importing soil. That's like
sediment or rock is scientific. Soil becomes
agricultural. Yeah.
Yeah, and that's a big no.
No.
But I mean, I guess to go back to the topic of this news story about reproducibility in geology, I mean, is it an issue? Yeah, but it also seems like it's an issue in every other field of science too. So I think at some point you just have to trust people that that they're good scientists. And
but it's trust but verified though. Like,
well, have you guys heard about, there was a group of people, I guess they were more in like in the humanities field, and they were purposely submitting bogus journal articles.
And to see if it would get through.
And they're getting published. Yeah. There's like it was some pretty crazy stuff what they were publishing. It was getting through. And the one guy, he was I guess he was, tenure track university or tenure track assistant professor. And I think he got fired over it, but don't quote me on that. I don't know what happened.
That's something you got to set up ahead of time. Be like,
no, yeah, and like this is probably for a different topic for a different day, but like the whole peer review, like.
I mean, I could go on for days about the peer review thing, man. That's a bunch of
just doing work for free for nothing.
Well, you're doing that, but then it's also like, I mean, I've had some issues where there's some stuff that I put in, like you look at like what the peer review, what they say to your work, and it's like, come on, like where are you coming from with this? Like, are you even in my field? Like, how do you not know this stuff?
Well, I just had comments back, and I was like, are we and I've as I get older, my comments when I make edits, and I'm like, I don't know how they're interpreting this, or I don't know if they're reading the same thing I'm reading, but I don't know where this comment, like, I have no problem like just being like, I don't know what they mean by this, but they're not right. And but like I will, on the other end, as a reviewer, I love reviewing articles, and I'm probably a minority opinion on that. Like, I love being a peer reviewer because it's like, oh man, this is fresh research. I love reading it, and then sometimes I read papers and I'm like, ooh, this is really bad, and I feel like I'm gonna break someone. Like, I don't want to break. Because I'm a very positive, optimistic person, but at the same time, like, ooh, why did this even get passed on to me? This is garbage.
I've had it where I've gotten papers to review, and I did the first round, and then I guess the people resubmitted it and they gave it back to me to re-review. And I was looking at my original comments and how they addressed it, and I was like, oh man, I was a jerk for what I said in the first one. I said that? Oh, sorry. I didn't mean to come out like that.
Try again, Dumbo. That's all his comment said. Like, nothing constructive. Just
anyway, we should probably wrap this up.
Yeah. Yep. So
Chris looks like he's ready to talk.
No, I'm
for hours.
Yeah.
Just keep on going, baby. No,
let's go. We'll get the whole years out tonight.
I think I'm out of news stories too. I don't even think I have any.
I've got one.
It's kind of like this is like, what was that?
I've got one, but I'm going to save it for Jesse's Corner for next episode.
Nice.
Oh, okay.
All right.
It's on It's on the Great Unconformity. That's a teaser.
Ooh. I put my hand on the Great Unconformity.
Yeah, I sat on it.
Ooh.
I had a news story up here. This is Jurassic Park gets it wrong again, but I feel like it's so easy to pick on Jurassic Park. It's kind of like,
Yeah. It's been 30 years.
Yeah.
So.
Oh, shoot. 30 years? No.
Pretty close.
It was the 90s.
Which was
the first one came out in 93.
Just yesterday.
I'm sorry. 27 years ago.
Come on.
Anyway.
There was supposedly something with Jurassic Park where when they did the reboot a few years ago, like they have all this information now about how the dinosaurs had feathers and stuff like that, and they're like, nope, want to keep it consistent. Don't want to, rock the boat. So,
or that DNA degrades after 50,000 years or something like that.
Oh yeah, we could do a whole episode about how Jurassic Park got it wrong, but then I would just be
they spliced it in with amphibian DNA. Come on, we all saw the movie.
Was it amphibian? I don't remember the
yes. Didn't you remember the little ride with little dino DNA?
Would it be better to do it with birds?
Again, 1993.
But they knew about birds because the last scene of the original Jurassic Park, they're riding off in the helicopter and you see the birds, and there's someone like Jeff Goldblum saying like what happened. I don't know. I thought there was something like
maybe.
All right, sounds like we need to do our homework before we get another angry message.
Stop talking.
I once, and I'll let my brother fact check me on this one. Once, in the early '90s, watched that on VHS 3 times in a row.
Nice.
On the couch, just rewind.
That's 4.5 hours of Jurassic Park right there.
Yeah.
Yeah. So being married to someone who didn't watch a lot of television or wasn't allowed to watch a lot of television, like in the summer they were allowed like 30 minutes a day, my wife and her sister, so they would like stagger it, like one would watch a half an hour show and then the other one would like stand in the hallway and listen to the other one's half an hour show.
Oh jeez.
Because like my kids they'll like what were they doing? They were just watching like Avatar for 2 hours or something. And that's a lot of television. I'm thinking there's been many a day in my childhood where I just come home, turn on the television, and like hours in a row.
I was raised on Nickelodeon.
Yeah.
Come on.
So yes, I'm right there with you, Jesse. I think I probably watched Batman back to back to back.
Oh, man.
So
My kids were watching Avatar this morning.
nice.
Yeah.
Yeah, The Last
never-
Airbender.
Yeah, oh yeah, Netflix.
Yeah. Yep. Which angers me because I pay for the cheap Netflix. So if they're watching something and I want to watch something, I'm low man on the totem. You know, the one paying the bill. That's a lie. My wife pays the bill, but still. Anyway,
Are there different tiers to Netflix? Should I be looking
yeah.
at the bill?
you can have like
What's-
one screen is like $10 a month. Two
Oh.
screens is like $15 a month. And
Yeah, I
then
think I got, like,
there's
I got the 16. I think I'm on the $16 a month tier.
yeah, whatever it is.
Speaking about tiers, next segue.
Chris,
Yes.
Chris,
Yes.
can you just read out your Netflix login and password over the air, please? Since it sounds like you're on some
That's,
sort of unlimited plan.
Unlimited, please.
Speaking of tiers, we've had some people asking us, how can you support the podcast? And the best way to support the podcast right now, there's a couple different ways, but check out our Patreon page, patreon.com/geologyflannelcast. If you like to support us, we got a couple different tiers. We have extra footage on there that we do. We just started doing it last week with Tim Davis, but we have some footage up there about the dinosaur wars. With Cope and Marsh back in the 1800s. So if you want to hear about that, sign up. Look into becoming a.
Yeah, and we're happy for anything. The $2 a month, all the way up
Anything.
to, we're thinking of instituting a diamond member where, Chris will be the godfather to your child. So
Yeah.
You're welcome in advance.
We'll do a Kimberlite member where
ooh,
we'll come visit you and take you on a field trip.
yes, I like it.
Yeah.
Yeah, you shower us with diamonds like a Kimberlite pipe, and we will shower you with Patreon
If you want to fly
exclusiveness.
if you want to fly us out to wherever you live, we will take you on a geologic tour of your backyard. So
You pick us up in your private yacht.
Yeah.
So
whatever.
Elon Musk, Elon, if you're out there, man, and you want to learn about some geology where you live, one of your many houses, he's selling all those houses. We can't talk to him.
Yeah.
Who has a lot of Bezos? Bezos must have a lot of houses. Johnny Depp has a crap ton of houses. Johnny, hit us up, baby.
Yeah.
All right.
So yes, check us out on Patreon, please. Anywhere from $2 a month to ?
Yeah.
Any little bit helps, and we've been getting some people that have been helping us out with the podcast, and we're extremely grateful. Thank you very much for that. Just helping us kind of pay the bills, some housekeeping work. So thank you so much. We're so grateful. Thank you for all our listeners. Even if you can't, if you're not able to help out financially, just a couple other things you can do. Just if you subscribe to our YouTube page, that's actually a huge help. So just look up. It's just Geology Flannelcast on YouTube. We've been putting up the full length podcasts and some short little clips from the podcasts on there.
Every view counts. Every hour of viewage.
That stuff helps.
Yeah,
leads to us getting another nickel a month.
Whatever your podcast, however
Your
you listen
platform.
to us, subscribe and rate us, especially on iTunes. For whatever reason, they're like the gold standard that feeds into other podcast platforms.
Yeah, and give us feedback. We'll take negative and positive. Chris will handle the negative feedback. Jesse and I'll handle the positive
love the
feedback.
negative feedback. Bring it.
Call me out, and I will apologize on air. Jesse's Corner is just going to be apologies from now on. It's just going to be me recanting everything I've said.
I love it.
Well, we're on Twitter at GeoFlannelcast, Facebook.com/GeologyFlannelcast. Excuse me.
www.geologyflannelcast.
We got a website, geologyflannelcast.com. Leave some comments on the website on each of the podcast pages. Leave some comments. Email us. Every once in a while, we do a listener questions episode. So you can just email us directly at questions@geologyflannelcast.com. Or there's a link on our website. You can click on the link to submit a listener question, and we'll get to that eventually when we do another listener question episode.
Listener question episode. All the listener questions are great.
Yeah, they really are. And I want to say 90% of them, I'm like, I have no idea.
Yeah, there's some really cool ones.
Let me look this up.
Yeah.
And those are really fun for us to do because
Send us your craziest nonsense.
it's literally like Stump the Geologist, because we do not, we look at them like, I mean, like I look at them when they get emailed to them, but we don't like really try to find answers for them until we read them on air. So it's
no, we do hours and hours of prep, Chris. Come on.
No, we don't, dude.
So it reminds me, every once in a while, depending on how I'm feeling, like I'll go into one of my classes, the beginning of class, the beginning of the semester, especially if it's a gen ed where like people aren't into geology. I'm like, everything relates to geology. Name something right now, and I can tie it to geology. Like, and
yeah,
I'll
like
just,
6 degrees of separation to Kevin Bacon.
Anything you've got right now, and I will tie. And it's super easy.
Yeah.
In reality, it's like.
I think I have the idea for our bonus footage for that we're going to put on Patreon.
Stump Jesse, yes.
Stump Jesse. So if you want to see, we're going to do this right after we end. So
literally
we're going to have some fun with this, because I was wondering what we're going to do for a bonus footage for this week. But that's if you sign up on Patreon to be a $5 a month member, you can see this footage, and we'll leave it at that.
You cannot stump me.
All right, here we go. This is going to be good. It's like the pay-per-view. Like when you watch the UFC, you see the stuff on Fox, and then, then it just all blacks out, and you go to the actual, UFC fight. All right. Anything else, gentlemen?
Yes. Don't forget the formatting formula, YouTube/C/formattingformula.com for all your word formatting needs.
Mm-hmm. Yeah. Check out that YouTube site.
Yeah. That's all I have for now.
All right. Well, thank you so much, everyone, for taking some time and listening. We really appreciate your time. We love our listeners. We got some awesome listeners. Keep in touch. Shoot us some emails. We love getting in touch with you guys. Oh, thank you. And one other thing before we end for the week, I have to give some shout outs. This is to Aaron on Twitter. We were talking back earlier in the month when we got the podcast back up and running. Aaron helped get us set up with one of the podcast sites to list us. So Aaron, I told you I give some shout outs on the podcast. Thanks so much for helping us out with that.
Aaron, and I hope you listened all the way to the very end for that shout out.
Outro to the last minute.
Poor Aaron.
Yeah.
Who was Angela we shout out right away for calling us out on Facebook. Poor Aaron, who actually did a lot of work for us for free.
I'll make a post-it for Aaron for next week.
There you go. Thanks, Aaron. You get 2 shout outs.
He's the real hero of the podcast. Yeah. All right.
No, but we do love Angela's comments as well. We always want to know if we got something incorrect. So
yeah. Be respectful.
Yes. And she was very nice. Very, very nice.
She was awesome. She had some great stories about growing up in Idaho. It was awesome.
Yeah. And it was funny. Jesse, on his phone, he doesn't have Messenger. So all you can see is the first few words of a message. And it just says, I don't mean to be a troll, but and he's like, oh, man.
I don't want to look at this.
So, no, she was very, very nice, very respectful. Thank you very much.
All right, guys. Thanks so much for listening. We love you guys, and we will see you guys next week. And we do have a guest for next week, so you'll see who it is. It'll be a surprise. Tune in. Yep. All right. Goodbye. Love you guys.
Bye.